Hello, thanks for tuning in. Today I'm going to be going over a question that's actually in the homework packet. This is a question from chapter 6 and it's question number 9. Now, this question gives us some information about the lifespan of men in industrialized countries. Just noticed my bell-shaped curves, my distributions, they're never quite bell-shaped curves. But I'm trying my best and you guys get the picture, right? So, the information that this gives us is that on average in industrialized countries, men live to be about 70 years old, and the standard deviation for that distribution is 6.3 years. So, I'm going to go ahead and mark off our mean, which is 70. And it's asking us for this particular question. I'm just going to move this down a little bit. Oops. Sorry guys, I'm having all kinds of technical difficulties here. Okay. So for this particular question, it's asking us what percentage of men live between, 95% of men live between the years of blank and blank. So basically what it's asking is to find the middle 95% of men's ages. So if we think about this, it's asking for the middle 95%, which is, the majority of it. So let's think here. It wants all of this, right? That's like 95% of the graph. So how are we going to find out what that 95% is? Well, the easiest way to do that is to find out these areas over here, find out what they are. So we got to think here, 95%, that leaves 5% total, right? Left over from 100%. 95 plus 5 is 100. And then we have this on two sides here because it's asking for the middle 95%. So what we're going to have to do is we're going to actually have to divide that 5% into 2 halves. So I know this might be kind of confusing, but try to follow along. So we need to find 2.5% here and 2.5% here. Now remember, as always, I know you guys probably get sick of hearing me say this, but area equals percentage. Right here, we're looking at a percentage. So what we're going to do is we're going to find the area of, let's see here, 0.025, because we moved the decimal place over 2, in the tail. And we're going to find which z-score corresponds to this area. Okay? Like I said, I know it can be kind of confusing, but stick with me. So I'm going to go over to my z-table here. So I always have leftover numbers. So I'm looking in the smaller portion, and I'm going to find 0.025. So let's see. It's going to be, looks like pretty far down. Be careful not to just pick 0.2 or something like that. That can be easy to do, but you always want to make sure it has that extra 0 there. Just be really careful that you're counting all your decimal places correctly and all that. So here's 0.025 in the smaller portion. I'm going to go over here and see what z is associated with that. So a z-score of 1.96 is associated with the upper 2.5% of the distribution. Now, remember that these are symmetrical. So, don't freak out. I'm going to do the same thing over here except negative. I hope that makes sense. I hope you guys remember that they're symmetrical and that it's going to be the same on this side that it is on this side. So because this is kind of a challenging problem, I'm just going to explain that one more time what I did and why. So here's our distribution. Oh my goodness, I'm struggling with it. You know what? We're going to go with it. Here's our distribution. Here's our mean of 70 years. And it's asking us to find the middle 95%. So in order to find the middle 95%, we have to find the upper 2.5% and the lower 2.5%. Because we split that 5% in half and put, half at the highest end and half at the lowest end. So when we did that, we realized that a z of 1.96 corresponds with the upper 2.5%, and a z of negative 1.96 corresponds with the lower 2.5%. Now what I'm going to do is I'm going to convert these to a raw score. We were given the z-score, well I guess we found the z-score, and the question's asking for a raw score, it's asking for the age, so we're going to convert from a z-score to a raw score. Thankfully we have that on our formula sheet over here. So we have our z-score, we need the raw score, so we're going to be using this. This formula here says x equals mu plus z times the standard deviation. So remember that we were given mu and the standard deviation up here, so we're just going to plug that right into the formula. Let's see if I can put this in a place that's a little bit easier for us to see. I'm actually going to draw it right on top of the graph. Okay, so for our first x value, which is going to be the lower age in this little sentence here, x equals mu, which we were already given as 70, plus z, we're going to use our first z-score here. Well, I think I said the lower just now, so we'll use the negative one. So we're going to do negative 1.96 times our standard deviation, which we were given is 6.3. Okay, so I'm just going to plug this into my calculator. First, I'm going to do a negative 1.96 multiplied by 6.3, and that gave me negative 12.35. So then I'm going to subtract that from 70. So 70 minus 12.35. So that gave me x equals 57.65. So that's going to be our first number here in our answer. 57.65. We're going to do the same thing for the value over here. We're just going to plug in positive 1.96 instead of negative. So x equals mu plus z times the standard deviation. 1 second, I gotta go take my food out of the oven, sorry. Okay, so our mean is 70. We said this time we're gonna do 1.96. And our standard deviation is again 6.3. 1.96 times 6.3 is 12.35. This time we're adding it instead of subtracting it. So 70 plus 12.35 is 82.35. So This is our upper value, this is our lower value. So we're going to say that 95% of men live to be between the ages of, what do we say here, 57.65 years old and 82.35 years old. Now, I know that this was, again, probably one of the more complicated questions you guys have come across so far, so I'm just going to run through it one more time to make sure it makes sense. So the question asked, it said 95% of men live between the ages of blank and blank years old. We were given the mean of 70 and a standard deviation of 6.3. We were asked to find the middle 95%. It says 95% of men will live between blank and blank. It's asking for the middle 95, so I just marked that off with a rectangle here. And I realized, okay, there's 5% left over, so we're going to do half of that 5% at the top, half at the bottom. 5 divided by 2 is 2.5. So 2.5% here, 2.5% here. I know the area equals percentage, so I'm going to convert this percentage into a decimal, like an area. So I just do that by moving the decimal place over 2 points, which leaves us with 0.025 on either side, 0.025. And I looked over at my Z chart. I looked for where 0.025 was in the tail. It told me that that happens at Z equals 1.96. And then I remembered that our distribution is symmetrical, so it's going to be the same on the other side except negative. And then I just used my formula to convert from a Z-score to a raw score. And I plugged in the mean and the standard deviation that were given to us in the original problem to convert these into these here into the raw scores, which is the years.